Welcome to GateX AML. In this video, you'll learn the concept of the quadratic forms. Okay. Till now, you have seen the matrix representation of the linear systems. Okay. Why we convert into matrix form? Because we can find the different properties in the systems and then we can easily reduce them. The goal of linear algebra is to, as I told before also, it's to minimize, to solve the problems efficiently. So in the previous, we use the linear equations, that is x plus y plus z equal to some k, something like that. Now, if it is a quadratic equation, quadratic means, you already know what is a quadratic equation. Quadratic means it is of the form x square, that is a polynomial, x square say plus 2x plus 1. So it has all the orders x square, x power 1, x power 0. Okay. So now we'll try to represent this in our quadratic forms. So let us say there is a function. This is one of the easiest topic. If you refer to any textbook, you may feel it very complicated. So please understand it carefully. Very simple, easiest topic. Let us say there is a quadratic function represented as q of x. So this function is given as say a of x square. Okay. Now, suppose I have function of two variables quadratic. Let us say I will write it as x1 square plus 2x1 x2 plus x2 square. This is nothing but what? X1 plus x2 whole square. Right. So this represents quadratic equation. Similarly, it can be a quadratic equation of three variables. Okay, up to n variables. Now the question here is, quadratic forms means what? The quadratic equation, how can you represent in your matrix? See, already we know matrix helps us to solve our systems very efficiently. So you have done it for linear systems. Now, if there is a quadratic equation, how can you represent it in the matrix form? Let us try to understand that. So let's say we take this equation. Okay, before I represent or present the formal definition, let us represent and take this example and try to understand. This one, I can write it as x1 square plus x1 x2 plus x2 x1 plus x2 square. Okay, I have just expanded this. X1 x2 plus x2 x1 is same, so it will give 2x1 x2. Okay, now let us write some coefficients. So it is 1 here everywhere. In general, let us write, say it is a x1 square plus say k x1 x2 plus, so let us also say this k x2 x1 because they are same. If I add that, I should get 2. In this example I am saying. So plus b x1 x2 square x2 square. Okay. So now I'll make it more general so that you can represent in a matrix, so you can understand it, mapping. Let me write this as a11 x1 square, the coefficient. Then let me write this as a12 x1 x2 plus a21 x2 x1 plus a22 x2 square. See, what is this? Let us make this number same, 1 1 x1 x2. So a12 a21 is x2 x1. So if I write these two, how will I expand? I can write it as a11 into x1 x1. This remains same. 2x1 plus, we'll write a22 into x2 x2. Now does it make sense? So there are four variables, right? Four coefficients. Let me represent it in a matrix. How can I represent it? So this is say 2 cross 2 matrix. I have four coefficient, means 2 cross 2 matrix. Okay, 2 cross 2. Now, so already know this is row 1, row 2, column 1, column 2. I'll represent them as this is A11, A12, A21, A22. So this equation, the quadratic equation, I have converted into matrix A in this form. This is the quadratic forms using matrices. Hope it's simple, right? You understood it. So there are some properties that you have to study. Okay. So we'll go to the formal definition next. But one more thing I want to tell you. So in general, how did you write this? I want to represent the q of x. So some quadratic x. So how will I write? This is nothing but summation of, so starting I equal to 1, j equal to 1. That is what index. This indicates I, this indicates j. So what I am doing here, I am writing it as a of ij into xi into xj. That's what I am doing here. If I expand it for n equal to 2, I'll get this back this equation. So this is the standard representation of quadratic form. So for n variables, you will write like this. Now, here if you observe, these two elements will be same. To take this example, see, this I have split into two variables. Both will be same. So if I take like ax square plus 2ab x1 x2 plus x2 square bx. Now 2ab means what? Or let us say 2k. ab is 2k. Now I split this into k x1 x2 plus k x2 x1, right? This 2k. So that means this k value will be in the matrix 1 comma 2, 2 comma 1 are same. So that means for this a of ij will be always equal to a of ji. This is the mean. So this is the quadratic form and these two are equal. If these two are equal, that means what? This matrix is a symmetric matrix. That is a equal to a transpose, because these two elements are same and this is the principal diagonal element. These two elements remain same. So that is, it is a symmetric matrix. Hope you got the definition. What is a quadratic form? So that's why they are written here. So it is nothing but summation of I equal to 1 to n, j equal to 1 to n, aij xi into xj. Okay. Now, to further simplify, I can write it in this form also. What is that? This is the form that we'll be using. Q of x is equal to, so x is a vector. It is the variables, right? So if I have x is equal to x1, x2 up to xn, these many variables. I'm taking the quadratic form of these variables then into your matrix, and A is a symmetric matrix here, into my x. Okay, and A is equal to A transpose. Okay, so this is a standard form. Now, next. So sometimes if your matrix A is not symmetric, if to apply this transpose, that is q of x equal to x transpose into A dot x, this should be symmetric. That is the condition. So if it is A is not symmetric, how will you make it symmetric? You already know. To make any matrix symmetric matrix, I take A plus A transpose and divide by 2. So that what it will become now, q of x equal to x transpose into A plus A transpose divided by 2 into x. So this is the standard notation. So this is the matrix notation for your quadratic equations. Now, to make more simpler, okay, to simplify it further, so you know the concept of diagonalization. So you have learned. Okay. Similarly, if I find a matrix P, and P should be what? An orthogonal matrix here. If P is an orthogonal matrix, then I can diagonalize it as P transform into this matrix A, coefficient matrix A into P equal to D. The diagonal matrix means what? You already know the concept. Diagonal matrix means it will have only diagonal entries and all the other entries will be 0. That means my matrix is reduced to only diagonal matrix. And how will you find the diagonal elements? It is nothing but the eigenvalues of that matrix A. The eigenvalues of the matrix A is nothing but D. It is only diagonalizable if there exists a orthogonal matrix P such that P transpose into A into P is equal to D. Okay. Now you can still further simplify it. So instead of writing x1, x2 and all those things, because we'll get x1, x2 plus x2, x3 like this. So I want to convert this into single variable. So it will be easy for me to solve. So for that, what they will do, if it is diagonalizable, then you set y is equal to P transpose x. That is, now in your Q of x, this is x transpose Ax. In that you set y is equal to P transpose of x. So this is this into this, we will call it as y. So it becomes y transpose into dy. So I converted this matrix into diagonal matrix and I applied this y transpose. So what is that means? It means I am converting this all x1, x2 into a single variable y or yi. So the diagonal elements are given by the eigenvalues lambda here. So how will this be? This q of x, now it will look like summation of I equal to 1 to n lambda I into yi square. So my initially this form is converted to this form. So this is nothing but summation of I equal to 1 to n, summation of j equal to 1 to n. So my q of x is equal to, I wrote it as a of ij into xi xj. This now becomes equivalent to summation of I equal to 1. I have reduced it to eigenvalues of that matrix A and then yi square. So this is simpler form than this. Here I have to put two loops, that is summation of I equal to 1 to n and summation of j equal to 1 to n, and then find this. Now all this xi xj are converted to yi only. That is the, now it is simplified form of this. Okay, how you got that? So if it is diagonalizable, then P transform A P equal to D. You substitute y equal to P transform x. Okay, so this becomes y. So y transform dy. So A is converted to dy. So diagonalized matrix contains only eigenvalues as a diagonal element. So this becomes this form. This is the simplest form. Okay. So let us take an example. You'll understand that. Q of x1 comma x2. So it's a quadratic equation given like this. Now how will you find the matrix A for this? A is equal to, how many are there? So 4 variables. So I need 4. So split this matrix into 4x1 square plus 2x1 x2 plus 2x2 x1, because these two are symmetric, right? That's why I'm splitting them. X2 whole square. So this is A11 4. What is A12? This is 2. A21 is 2. A22 is this 1. Now you find the eigenvalues of this. So this I will get it as lambda 1 equal to 0, lambda 2 equal to 5, 2 eigenvalues. Now suppose say that this is the orthogonal matrix. So P is given as root 5, 1 by root 5 minus 1 to 2 by 1. So how will you find this is orthogonal? This matrix is orthogonal because see, length of each is unit vector, that is minus 1. So 1 square plus 2 square divided by root 5 is equal to 1. Both the columns has 1. So, and then the dot product, minus 2 plus 2 is 0. So, this is a orthogonal matrix. If it is an orthogonal matrix, how will I form my equation? Y is equal to P transpose into X. So, take the transpose of this and then you substitute those values. So, if there exists P transform X, that means what is P transpose? 1 by root 5 into minus 1 to 1. Okay. Therefore, according to my definition, Q of X can be written as summation of I equal to 1 to n lambda I into yi. What is lambda I? There are two values, I equal to 1 to n. So lambda 1 is 0. So 0 into y1 square plus what is my lambda 2 is 5 into y2 square. So that is the answer. Okay. See, this matrix is given just to show you this is diagonalizable. Next. There is another concept here, classification based on eigenvalues. So there are different types. We call them as positive definite, positive semi-definite, negative definite, negative semi-definite, and indefinite. So why these all things are required? When you go to machine learning algorithms, there you require. When you go to calculus, you may require. You will be using higher order differentials or higher order equations. Okay, what is this and how they help is? See, what is positive definite means? You can just remember it as definitely positive. So positive definite means if q of x, quadratic function is always greater than 0. This is important. Always greater than, strictly greater than 0. For all x not equal to 0, that implies what? All the eigenvalues are greater than 0. If all the eigenvalues are greater than 0, then definitely it's a positive definite. So this helps us to find minima in calculus of this curve of this quadratic equation. This positive definite helps us to find the minima of the equation. Positive semi-definite means q of x is greater than or equal to 0, not strictly greater than 0. That is, all the lambda values are greater than or equal to 0, but the value is positive or 0. It is not negative anyway. So this is positive semi-definite. What is negative semi-definite? Negative means definitely less than 0. That is, q of x is strictly less than 0, not 0, less than 0. For all x not equal to 0 and all the eigenvalues are always less than 0. This helps us to find the maxima. Then negative semi-definite means it may be less than or equal to 0. The q of x, the function value can take less than or equal to 0, but it is always negative only, but it can contain 0 also. And the eigenvalues will be less than or equal to 0. Indefinite. Indefinite means qx takes both positive and negative values. So all the lambda means its eigenvalues are either negative or positive. This we call it as, actually in the calculus you understood, called as saddle point. Okay. So these are the some concepts. They are simple. Now in the exam they may ask testing the definiteness. So in the machine learning we'll see its application. Now we'll just solve the problems. What is determine the nature of this? Nature means, is it what kind of definiteness it is, or is it indefinite? So they are given this equation 3x square plus 2x1 x2 plus x square. I first find the matrix of it. So this is, I can write it as 3x1 square plus 2x1 x2, sorry, x1 x2 plus x2 x1 plus x2 square. So this is 3, 1, 1 and 1. My eigenvalues for this will be, to find, it will get 2 and 2. See, both the eigenvalue lambda 1 and lambda 2 both are greater than 2. That means what it is? Positive definite. That means what? For whatever value of x, See how beautiful it is concept. See, if I want to check whether it's a positive or negative, how can I check? So by just checking this definiteness, if I ask you this, if I only give this equation and then tell whether it's a positive, it takes positive or negative, or it takes a maximum or a minimum, how can you find? It will become difficult, right? So if I calculate the eigenvalues, to calculate the eigenvalues, first I have to get the coefficient matrix. So this is how your quadratic forms helps in solving this quadratic equations. Hope you understood this. Now we'll write the canonical form. You already have seen this. By applying an orthogonal transformation, that is y equal to P transpose x, where P is the orthogonal matrix, a quadratic form can always be written as. So in general, Q of x, if there are n lambda values for that matrix A, diagonalization, I can write them as lambda 1, lambda 2, y2 square plus so on up to yn square. That means you are converting your x, this x vector, that is you will have 1 x2 up to xn into directly quadratic, all are of order 2 here. So this may x1 x2 may be like this, x1 square plus x2 1 plus x2 1 plus x2 3, something like that. So instead of this, I'm converting everything into quadratic form. So that makes it simple. Even if I want to find the maximum minimum for this, for finding for this, it is become difficult. Okay, there are a lot of constraints here. But if I convert to this form, it becomes very simple. That is the help of your canonical form. How you get the canonical form? So you get a orthogonal matrix and then check if it is diagonalizable. And then find the eigenvectors for that matrix A, that becomes a diagonal matrix. And then substitute y equal to P transpose, where P is a orthogonal matrix. So for example, canonical form in 3D. So again, this is giving the same equation. So find out the matrix A, and which should be symmetric. So check here, it is symmetric here. So therefore I can find the eigenvalues for this. They are 0, 1 and 5. And then you get this y equal to P transpose x. So Q of x will be written as lambda 1 into y1 square plus lambda 2 into y2 square plus lambda 3 into y3 square. So lambda 1 is 0 plus 1 y2 square plus 5 y3 square. So what exactly it means? See, all these quadratic equation, they, for example, say initially I took q of x equal to ax square. What is this? This is nothing but a parabola like this. Okay, it represents x square, ax square. So based on your again definiteness or the eigenvalues, I can tell the shape of the curve. So it will be easy to visualize. If in that previous equation in the canonical form, if all my lambda or all my eigenvalues are greater than 0, that is positive definite, then it is a implies the ellipsoid. Okay, you can refer to the Google or internet to check how they look. Ellipsoid. Mixed signs means it's a hyperboloid. If it is 0, then it is a paraboloid. Okay, it looks like a paraboloid means it looks like a parabola. Hyperboloid means it looks like a hyperbola. Ellipsoid means it looks like something like this curve. I'm not trying complete ellipse, it's some kind of curve. Okay, this helps us in finding the optimization in the optimization of your many algorithms. It helps us. This is an example for saddle point. So if you take this equation x1 square minus x2 square, so here this, what is this matrix here? If I convert this 1, the x1 x2 are 0, and this is minus 1. So what are the eigenvalues for this? 1 minus lambda into minus lambda plus 1 equal to 0, or this is lambda square equal to 1, lambda equal to plus or minus 1. See, lambda is greater than 0 also, lambda is less than 0 also. So it's a saddle point. It is indefinite. Here, indefinite, mixed. Okay. So where do you apply this? So you apply them testing definites of symmetric matrices, optimization problem as I explained with constraints, analyzing conic sections and 3D surfaces, and machine learning algorithms for diagonalization and principal component analysis. This concept you will see in your machine learning. Okay. In the next video, we will solve few problems on this topic, quadratic forms, and then close this topic. Thank you for watching. Please like, subscribe, and share.